When you first power on your HMI, the default basic screen will appear, signaling that the device is ready for configuration. Before any communication can take place, it's essential to assign an IP address to the HMI. This step is crucial because without a proper IP address, the HMI cannot connect or communicate with other devices on the network. Think of the IP address as the HMI's unique identifier, allowing it to send and receive information. In this video, we'll walk through the process of setting up the HMI, assigning the correct IP, and configuring the necessary communication links to ensure seamless operation. Once the HMI is powered on, navigate to the Settings page. Here you'll find several configuration tabs, but our focus is on the General tab. This is where you'll assign the IP address, which is a fundamental step for enabling communication. The interface is designed to be user-friendly, guiding you through each field that needs to be filled. Assigning the correct IP address ensures that the HMI can be recognized on your network, paving the way for further setup steps. In the General tab, locate the IP address field. Here you'll need to enter the IP address 122.168.0.30, as shown in the image. This step is vital because it uniquely identifies your HMI on the network. Double-check the IP address to avoid any communication issues later. Once entered, confirm the settings to ensure the HMI is now accessible via this address. This forms the foundation for all subsequent communication and project setup steps. With the HMI's IP address set, it's time to move to the HMI software on your computer. Open the software and create a new project. This project will serve as the workspace for configuring communication links and device parameters. Once the project is created, locate and double-click on the Link1 tab. This is where you'll define the connection between your HMI and the external device, setting the stage for seamless data exchange. Inside the Link1 tab, you'll need to assign several key parameters. Set the link number to 1 and the link name to Link1 for easy identification. Choose Direct Link Ethernet as the link type, and select Modcon Corp Modbus Device Slave TCP IP as the device. These settings establish the communication protocol and device type, ensuring compatibility between the HMI and the connected device. Don't forget to set the error message timeout to 5 seconds, which helps manage communication errors efficiently. After configuring the general link settings, click on the Parameter tab to define the communication parameters for the RTU. Here you'll assign the RTU's IP address as 122.168.0.20 and set the port to 502, which is the default for Modbus TCP IP communication. The node address should be set to either 255 or 1, depending on your network configuration. Lastly, set the timeout to 30 seconds to ensure reliable communication even if there are brief network interruptions. To ensure successful communication, the RTU must be configured with the same settings as the HMI. This includes matching the IP address, port, and node address. Consistency between the HMI and RTU settings is crucial for establishing a stable connection. Double-check each parameter to avoid mismatches, which could prevent the devices from communicating properly. Once both sides are configured, the HMI and RTU should be able to exchange data seamlessly. Modbus TCP IP is a widely used protocol for industrial communication. It allows devices like HMIs and RTUs to exchange data over Ethernet networks. By using standardized ports and addressing, Modbus TCP IP ensures interoperability between devices from different manufacturers. Understanding this protocol is key to troubleshooting and expanding your automation system in the future, as it forms the backbone of many industrial communication setups. Before wrapping up, it's important to review all the settings on both the HMI and RTU. Ensure that the IP addresses, ports, and node addresses match exactly. Test the connection to confirm that data can flow between the devices without errors. By following these steps, you've successfully set up communication between your HMI and RTU using Modbus TCP IP. This foundational setup enables further automation and monitoring, making your system more efficient and reliable.